Okay, so let's look at problem B here. It says find the antiderivative or the indefinite integral of dx over 2 plus 9x squared. Again here, this is very similar to problems that we've seen before. You might start off this problem by thinking, okay, let's use u substitution with u being 2 plus 9x squared. Well, think about doing that. If we did that, we would have the derivative, which would be 18x, and we would need that to simplify with something, and it couldn't simplify with something. So standard u substitution would not work on this problem. So what I really want to do is I really want to think about this as the integral with respect to x of, well, isn't this really the square root of 2 squared plus 3x quantity squared? And all I was doing was taking the square root of both of those terms, so that's how I knew that. Square root of 2 and then the square root of 9x squared. That's how I got those two right there. And so what I realize is these are the things that I can do substitutions for. So step one, I'm going to let my substitution, I'm going to let a equal the square root of 2, and I'm going to let u equal 3x. Okay? So my hope is to get this when I go into step 4, that I'm going to get this to be the integral of, this is my hope, du over a squared plus u squared, right? Because that is directly one of the inverse trigonometric identities. So let's see what happens. We know what a is. That's perfectly fine. We have that working out. But we need to find the derivative of u with respect to x. So du dx in this case would be equal to what? 3. So dx, step 3 would be solve for dx. That would be du over 3. So what do I have to do? I have to go in and substitute in for dx. I have to substitute in for u. And I have to substitute in for a. So let me use a different color there. Oops, sorry. Let me go back to the highlighter. I have to substitute in for a. So when I do that in step 4, I was very, very close. It's not just du, it's du over 3. So let me kind of rewrite this right here to make it look a little nicer. So here I'm going to have the 1 over the a squared, which is the square root of 2 squared, that's good. The u squared, which is the 3x squared, that's good. And then this is times du over 3. So this is equal to 1/3 times the integral of du over a squared plus u squared. Okay? That is directly one of our trigonometric identities. So that's equal to 1/3 times, and then let's go back, it was 1 over a arctan of u over a plus c. So what's the idea now? Now I need to go back and substitute in for my a values, and I need to substitute in for my u value. So step 6, what would I have? I would have 1/3 times, 1 over a would be 1 over root 2, and then I'd have the arctan of u over a, which would be 3x over a, which was the square root of 2. So just cleaning that up a little bit. Oh, don't forget that plus c. Never forget plus c on indefinite integrals. Just cleaning that up a little bit, I'm going to have 1 over 3 root 2 arctan of, it's 3x over root 2. I don't know what you want to do there. If you want to rationalize the denominator, I'm perfectly fine with you leaving it like this. So would WebAssign, they'd be fine with you leaving it like this as well. So I'm just going to leave it in that form right there. So again, a u substitution problem, but it wasn't just u we substituted, it was also a that we substituted. Okay, let's see if we can go with another problem here. Another problem that we would have here is the integral of dx over x times the square root of 4x squared minus 9. Okay, so what's my key here to knowing that this is probably one of the trigonometric functions? Here I have a quantity squared minus a quantity squared underneath the radical. That's triggering me off. The idea here is that I hope it's equal to something like the integral of du over u times the square root of u squared minus a squared. So that's the formula that I'm hoping for. It's what it looks like. So let's see if we can do that. If I want to rewrite this integral, this would be the integral of dx over x times the square root of, notice 4x squared is the same thing as 2x quantity squared, and minus 9 would be minus 3 squared. Okay, and so step 1, after we've rewritten that integral, would be let a equal the constant, which in this case is 3, and u equal the inside of those parentheses, which would be 2x. Again, step 2 would be take the derivative with respect to x of both sides with the u, so du dx would be equal to, well, the derivative of 2x is simply 2. And then step 3 would be solve for dx, so dx is going to equal du over 2. So what happens? Let's go on to step 4 now. Let's replace everything in there. This is going to be the integral of, and I'm just going to do it as 1 over x, and then it's going to be the square root of, well, 2x squared would be u squared, minus 3 squared would be a squared, and then dx is equal to du over 2. So we're not quite there, and let me go ahead and highlight the substitutions that I just made. I made the substitution for dx, which was right there. I made the substitution for u, which was right there, and I made the substitution for a, which was right there. So what I didn't do is find out what x is equal to. So that's one more substitution that I need to do. I know if u equals 2x, then x would have to equal u over 2. Hopefully you agree with that. Just divide both sides by 2. So now I'm going to make one more substitution. Instead of x written here, I'm going to write that as u over 2, which would actually be 2 over u because it's in the denominator. So this is equal to the integral of, this would be a 2 over u times the square root of u squared minus a squared times du over 2. Notice my 2 simplify here, and I have the integral of du over u times the square root of u squared minus a squared, which is exactly what I wanted it to be. Okay? Now and only now can I integrate because I am of the proper form. I'm directly reading that formula off of the sheet. I'm not proving this integral. I'm using the antiderivative rule on the sheet. This has to be equal to 1 over a times the arc secant of the absolute value of u over a plus c. There's no simplification to be had here. There's just a bunch of substitutions we have to do. We have to back substitute for a, and we also have to back substitute for u. So in this case, what would we have? 1 over a was 3, so that would be 1/3. And then we'd have the arc secant of the absolute value of u. Well, u was 2x, so this would be the absolute value of 2x all over a, which again was 3. And then we have our plus c in that case. So what I'm ending up with, sorry, that was step 6 as back substituting. Okay, so what I'm ending up with is 1/3 arc secant of the absolute value of 2x over 3 plus c. And there it is right there. Not saying it's super easy on that problem, but it is directly of the form of one of those antiderivatives. When you go to Calc 2, this is one of the first things that they're going to test you on is, do you remember your integral rules? And they're certainly going to harp on the inverse trig functions. So make sure you know this for the final. Make sure you know this when you move on to a Calc 2 course. Okay, let's move on to example 2 here. So example 2 is find the antiderivative of dx over the square root of e to the 2x minus 1. And so what I really want to do is see that, look, this definitely can't be a U-substitution. If I used U-substitution, it would be e to the 2x minus 1, but I most certainly don't have the derivative of that to simplify out anywhere. So U-substitution is not the technique. I need to realize that this is of the form. I want to look at this as the square root of something squared minus something squared. So this would be e to the x quantity squared minus 1 quantity squared. That's what I'm looking at right there. So let's continue here. If I go to step 1, let's just see what happens here. We're going to let a equal 1 and u equal e to the x. Step 2 is find the derivative of u with respect to x, so du dx. The derivative of e to the x is e to the x. So step 3 here would be find dx. So dx would equal du over e to the x. Okay? So now what do? We substitute in, most certainly for dx, I substituted into the wrong one. So let me highlight the proper place. I'm substituting into this one. I'm substituting in for dx. I'm substituting in for u. And I'm substituting in for a. So there's a right there. So let's see what we have here when we do that. This is the integral of 1 over the square root of, well, that would be u squared minus a squared. And then we'd have this times du over e to the x. Well, that's a little bit of an issue because that e to the x doesn't simplify. But what I want you to notice is that e to the x is really just u, isn't it? E to the x is u, the other highlighted red part. Let me make sure I highlight the green part too so you can see that. Okay, the other highlighted red part right here, we know that e to the x is simply u. So if I do this, right, this turns into the integral of 1 over u square root of u squared minus a squared du. This is a beautiful substitution problem because that's the exact integral that we wanted. So when we back substituted it, I got the exact definition of the antiderivative from above. So what is this according to our rules? Make sure you have that rule written down. It's going to be 1 over a times the arc secant of u, the absolute value of u over a, plus c. No simplification to do there. I'm going to go straight to the answer line on this one. So all we need to do is back substitute for a and back substitute for u. Oops, sorry, give me 1 second. Back substitute for u. And so when we do that, what we would have is 1 over a. A was just 1, so that's just a 1, so we don't even need that. And then we'd have the arc secant of u over a. Well, u is e to the x, so it'd be the absolute value of e to the x, but that's always positive, so we don't even need the absolute value. All over a, again, a is just 1, so that's all that it is, and then it would be plus c. So I'm getting the arc secant of e to the x. I put the absolute values there, but it's absolutely not necessary, plus c. Nice little U-substitution problem there for you, okay? All right. So let's look at example 3. Example 3 is not going to be a fun one. I can already tell that because we have an x plus 2 on top. So we're actually going to have to do most likely 2 separate integrals on this problem right here. It's going to be 2 integrals with U-substitution. But let me see why. Why am I just looking at that knowing that this problem isn't as easy, knowing that this problem is more of a pain in the butt? Well, here's why. When I look at it and I look at the bottom, I see 4 minus x squared. So the first thing I notice is both of those things are squared, so that's making me think inverse trig functions, right? Another thing that I'm thinking is, what if I let u be the inside? So u would be 4 minus x squared. When I have the derivative of that, it would be negative 2x. Well, that is not going to simplify or cancel out the x plus 2 right there. So I know u substitution is not the right technique. So what is the right technique on this problem? Well, the right technique on this problem is not something that you may have thought of immediately, but let's actually separate this into 2 separate integrals. X over the square root of 4 minus x squared plus, and that's with respect to x, plus the integral of 2 over square root of 4 minus x squared with respect to x. Now when I do this, I have 2 separate integrals that I need to worry about. I'm doing 2 completely separate problems. So let's look at the first problem. The first problem is a U-substitution problem, so I'm looking at the integral of x over the square root of 4 minus x squared. Let's let u be the inside, so u would be equal to 4 minus x squared. Step 2 again is find the derivative of both sides, so du dx would be the derivative of 4 minus x squared is negative 2x. Step 3 is find that dx, so dx would be equal to du over negative 2x. Step 4 would be rewrite just that integral, so that's the integral of x over the square root of u. And then this would be du over negative 2x. Notice the x's simplify here. The constant multiple is a negative 1/2. I'll bring that out in front. And this is the integral of u to the negative 1/2. Let me write that more clear. U to the negative 1/2 du. That's something that I can integrate. So step 5, I'm going to actually integrate this. This is going to be negative 1/2, and then the integral of u to the negative 1/2, negative 1/2 plus 1 is u to the positive 1/2. Then I have to divide it by 1/2, which is the same thing as multiplying it times 2. So simplifying that, I would get, well, it would be negative the square root of u is really what that is, plus c, of course, but I'll add the plus c at the end. And so the only thing I have to do here, let me start using my highlighting color showing you where I did these things. So here was my u, and here was my dx that I swapped in. So let me back substitute for u in this case. When I back substitute for u, that's my step 6. All I am getting is negative the square root of u, which is 4 minus x squared. Of course, plus c. So that is just the first integral, right? I still need to do the whole second integral and then add those two things together. So what am I seeing on this one right here for the second integral, which is the integral of 2 over the square root of 4 minus x squared? What am I seeing this as? I'm seeing this as the integral of 2 over the square root of 2 squared minus x quantity squared. So this is one of my trig identities, or close to it. I'm going to let a equal 2 and u equal x. Again, step 2 is take that derivative of u with respect to x, so du dx would be equal to 1. And step 3 is solve for dx, so dx would equal du. I have a bunch of substitutions I need to make. I need to substitute in for dx. I need to substitute in for a. And I need to substitute in for u. So when I do that, I end up with, let me go to step 4 here, I end up with the integral of 2 over the square root of a squared minus u squared times du, which is equal to 2 times the integral of du over the square root of a squared minus u squared, which is exactly what one of our inverse trigonometric functions were. Okay, what was the rule? The integral of du over the square root of a squared minus u squared, that's a u by the way, so this would be equal to, directly using the rule, would be 2 times the arc sine of u over a, and then of course we have the plus c. Okay, so again we need to back substitute for a, and we need to back substitute for u. So that's our final step for this piece of the integral. So this would be equal to 2 arc sine of u in this case was x, a in this case was 2, so that would be x over 2 plus c. So what do we need to do now? We need to take the first piece, which was negative the square root of 4 minus x squared, tie it together with the second piece, which was the arc sine, or 2 times the arc sine of x over 2 plus c. Putting those both together, we're able to get the answer to the problem, which would be negative square root of 4 minus x squared plus 2 times the arc sine of x over 2 plus c. So that would be our final answer, is adding those two pieces together. So a lot of work on that problem. You had to separate it. You had to do 2 separate integrals. One of them involved a traditional U-substitution with the power rule. One of them involved our inverse trig identities.